Hello, guys. Good evening, guys. Hello, yeah. Good evening, guys. Hi. Can you hear me, guys? Hello. Can you hear me? Uh, Zoeb. Like these problems are really interesting. Okay, if you really love mathematics and if you really work a bit hard, then I think it will not really be hard for you. Hello. I'm just waiting for the people to join. Yeah, what will I tell? Yeah, the seminar is only happening on YouTube. Yep, it's live. But I've sent the links to the groups. Hi Radhika. Hello guys. Hello Anand. Hi Keshav. Hi Audrija. I'm just waiting for the people to join. So let's see. So today's selection of today's selection of problems are really interesting. They are difficult, of course, but they're interesting. So I don't know whether I will be able to do all the problems over here, but we will try surely. Hi Swati. Hello, Kanishk. Hello. So let's start. Okay? I hope all of you can hear me properly. And okay, so regarding okay, so regarding the problems over here we will discuss today. It's all about and all. By the way, if you want to be totally at par with the class, please click on the live okay button so that you can get to the perfect time point. So let's start. So it's a geometry problem today, first of all, and it tells you that asks you rather that if ABCD is a proper square, it's shown in the diagram, and it's folded along EF such that A goes to point A dash, okay, and D goes to point D dash, okay. And correspondingly, the line A dash D dash, okay, cuts CD in G. Okay, it will be not A dash D dash. I think it will be yeah, A dash D dash. I'm so sorry. A dash D dash cuts CD in G. Okay, show that the radius of this circle CG A dash equal to in radius of G dash this one plus in radius of this one. Okay, this is what you have to prove. It's in radius, okay? Hi. It's in radius. So I will give you 2 minutes to think about it, and then I will get back to you with the idea of the solution. Think about it. Think about it. How can you link the circles, link the triangles, and the in radius together? Okay, think about it. What's on your mind? Hi, Radha Krishna. Gadapali. So you have one green triangle, one yellow triangle, one pink triangle, and you have to tell that the in radius of the green triangle and the in radius of the corresponding pink triangle are summing it up to make the in radius of the yellow circle. Okay, that's your idea. Okay, yeah, so one idea that people are giving here is that people are asking me to use. So do you know that in a triangle, this is the in radius, right? What is the in radius? This is the in radius. So if you just do it, it is a perpendicular over here. If you do this, then observe that if you take individual triangles, A, B, C, and these are R, the total area of the triangle will be what? Half into R into A plus half into R into B plus half into R into C. Okay, so it will give that half into R into A plus B plus C, which gives an R into the semi-perimeter. Therefore, the area of a triangle is R into the semi-perimeter. Okay, so it's a result we will be using. Okay, so let's write down the like result over there together. Now we can use that surely. So therefore, what it turns out, it demands, if we can use this result, it demands to find the area of this, relate the area of yellow and yellow in terms of green and pink. Okay, so rather it demands asks to, and also the perimeter. So therefore it demands sort of, in some sense, both are both are determined by the sides. So can you relate the sides of the green triangle, green, yellow, and pink triangle? So therefore it's a natural thing to ask, can you relate the sides of it? Okay, so how will you relate the sides of each of these triangles? Do you have any ideas? So what it means that we need to connect the area of these triangles and the hypotenuse, the same perimeter of these triangles individually. So in some sense, we are trying to connect these sides of these triangles together. Okay, how can you do it? What's really on your mind? Yeah, I can see the messages, but it doesn't contain anything really in I mean, okay. So you're giving a result for the in radius here in this case, Raghav. So for a right angle triangle, Raghav is giving an in radius result. Okay, let's see. For a right angle triangle, Raghav is telling that let's try to find the in radius. Okay, so this is the in radius R. There is R over here. Okay, R over here. Okay, and let's call this X and let's call this Y. So can you prove it, Raghav? How will you prove this? The in radius is related to the sides. So let's try to prove it. Okay. So as we have seen, it's half into R into twice R plus X plus Y plus the hypotenuse. Say it's C. Okay. Therefore, half into R into R plus X plus Y. But I'm just confused in the sense that okay. So it's X plus Y twice R plus X plus Y plus C, and it's equal to half into, okay, I see the point now. Actually this area is small. Let's see if we have better area for this. No better area. Let's try to do it here. So here's a right angle triangle. Let's see if you have a right angle triangle over here. No, we don't have a right angle triangle over here. Let's draw it here. So let's try to draw this here. Okay, since this is the R, this is R, it's because right angle triangle. These are right angle triangles. Okay, let's call this X, let's call this Y, let's call this C. Okay, the hypotenuse as Raghav was told. Yes. So now the area of this is half into R plus X plus R into R plus Y, right? R plus X and R plus Y, which is equal to half into R into the sum of the sides. Okay, R plus X plus R plus Y plus C. Okay, so let's try to do it here. Let's try to see what we can get from here. We get it's so let's try to get R plus X somehow on the right hand side. Okay, so you get R plus X minus X. So you get R plus X whole square into R plus X minus X. Okay. Uh, Plus r plus x into r plus y, half into r plus x plus r plus y into r plus y, which will get cancelled. This will get cancelled from here, and you get r plus r into r plus y minus of this minus of r into. Oops, I'm doing something wrong. Wait, I'm doing some calculation errors. Let's try to write it clearly. Half into r plus x plus r plus y plus c. Okay, you want me to use this x plus c. Okay, fine, very good. So therefore, he's asking me to use, observe that r twice r plus x plus y plus c is equal to what? This length is equal to this length y, right? And this length is equal to x. So you can use c as x plus y also. That's what his point is. So therefore, it's half into r into what? R into twice of r plus x plus y. Okay, so you get this cancelled out, and what you get over here? You get half r square plus xy plus rx plus ry equal to r square plus rx plus ry. Okay, and if you just multiply 2 over here, you get that. What you get? Let's rub this off. You get, so this gets 2 gets cancelled from here. Rx ry, oops, r square. So you get xy equal to r square plus rx plus ry. Okay, so therefore, okay, so tell me the easiest way out, Raghav. Maybe I'm doing some cross error over here. I'm sure I'm doing that. Therefore, it's r times actually, those so many messages I can't really see it. I think we should use Visa IQ from next day. I think live is not a good option, maybe. But yeah, we can do on Visa IQ. Let's see. Okay, so let's do it from the beginning again. So what we are trying to see is that we are trying to prove that what Raghav has told. If this is r and this is the r, therefore let's call this x, let's call this y, therefore this must be y, this must be x. Okay, okay, so what is the semi perimeter over here? It's half into r plus x plus r plus y plus x plus y. Okay, which is equal to r plus x plus y. Okay, that's the semi perimeter over here. Okay, I see now. So therefore, perfect. So now observe that this is c and this is r plus c over here. So same perimeter is equal to r plus c. Okay, so okay, I see now what you are telling. I'm so sorry for making this long. Yeah, so actually we are proving this. Okay, I'm sorry to make it confusing. So essentially it's this. I'm just explaining it again. So this is a right angle triangle. We are doing it in circle over here. Okay, and therefore it's R, the range radius is R, okay? And what is the in circle? That means these two triangles, these are tangents, right? These two are tangents, right? And since this is 90-degree, this is a square over here. Okay, and let's call this Y. This must be Y. Let's call this X. This must be X, okay? So therefore, what it turns out that the same perimeter S is equal to half into R plus X plus R plus Y plus X plus Y. Okay, so it turns out R plus X plus Y equal to R plus C, the hypotenuse. Therefore, S is turning out, R is turning out to be S minus C. That is half into A plus B minus C. That's what Raghav was telling. This is A, this is B. So therefore, it's A, B, C. Then the R is equal to half into A plus B plus minus C. That's very good. Can we use that here, guys? So we must use that. So let's write down this formula. So let's write down this result rather that we have derived together thanks to Raghav, that for right angle triangle with in radius R and the sides A, B and C, it's half into A plus B minus C. Okay? The in radius. Right, guys? So let's move ahead. Okay, so that's a very good idea. Let's move ahead. Let's not go through the hints. Okay, the hint is done in its own way. I really want you to put in your ideas. That's why it's a live session. Okay. So now let's go on to this part over here. If you try to see that what's going on over in this diagram, observe that this is theta. Okay, let's call this theta. This must be 90-degree minus theta, right? This is 90-degree. This is 90-degree, and therefore this must be theta, and this is 90-degree minus theta. This is theta, and therefore this is 90-degree minus theta. So what we are getting here, guys, we are getting that D dash F G is similar to C G A dash is similar to A dash B E, right? Right, guys? So if this is similar, then what will happen now? Let's try to observe the angles. For theta ke liye, for 90-degree minus theta and for 90-degree. So these are the corresponding angles over here. Let's try to figure it out. For theta, here it is D dash F. Okay. For 90-degree minus theta, here it is D dash G. And for 90-degree, it is GF. For this triangle, for theta, it is C A dash. For 90-degree minus theta, it is G CG. And for 90-degree, it is A dash G. Very good. And for the other case, let's write it above. For theta, 90-degree minus theta and 90-degree. For the other case, observe that it is for theta ke liye it's EB. For 90-degree minus theta is A dash B. And for 90-degree it's A dash E. Now also that A dash E equal to AE, okay? A dash E equal to AE. So you can write it as AE. And here D dash F equal to DF. So you can write it as DF over here also. Yeah, you have to know this stuff, Radhakrishna, because you have to know in circle, you have to know in radius, everything, okay? So you have to know this for this INMO and RMO problem, okay? So therefore it's important for you to understand this. Okay. Let's move ahead. So all of you understood this. So what we can get out of here, guys? What we can get out of here? These two are equal, these two are equal. So what we can really get out of here? So we have to use this corresponding aspect, right? Otherwise there is no use of it. So therefore, what do you get? Let's try to find one of the ratios, right? Let's try to find one of the ratios. That will be the corresponding side ratio, each of them, right? Let's try to find one of the ratios. Let's try to find. So therefore, observe this very carefully. Okay, I hope all of you understood this. Any doubts till this point? Okay, it's really confusing. Okay, okay. What should I? It's a difficult problem a bit. Is it confusing due to the way I am writing or something else, guys? Or the mathematics seems confusing? F dash D equal to plus E A dash is equal to G A dash. Okay, let's check it out. He's telling that F D dash plus. Okay, then you have to wait for some time for me to move on to the next problem. Plus E A dash is equal to G A dash. You're telling this? F D dash. Okay. So F D dash equal to DF and E A dash is equal to AE. Okay. E A dash is equal to AE. So how can it be equal to G A dash? Can you tell me somehow? Why do you think it's equal? Let's try to again rub this off and try to make you explain that, okay? So what we are trying to use here, we are trying to use here that in radius of a right angle triangle is half into the non-hypotenuse sum of the non-hypotenuse sides minus the hypotenuse side. This is the result we are using. We proved it, right? We are trying to use this result. So therefore, to try to use this result, what we need to prove? We need to prove that half of f d dash plus g d dash minus gf, okay, plus half of this corresponding triangle a dash b plus be minus a dash e. This is equal to, we need to prove that half of gc plus ga dash minus g dash a, ga dash. Okay, I need to prove this, right, guys? Okay, everybody is asking me to change the question. Okay. Okay, let's do it. I mean, I'm not really with the idea of changing the question, but still. Okay, let's do this problem. So every problem is today is hard. Okay, so I think if the second problem also you want me to change the problem, then I think I will go at the first problem again. Okay, so I will do that problem at the end. Okay, since it's popular demand over here, but it's hard. So we have to find the number of triplets x, a, and b, where x is a real number. and A and B belongs to the set. I mean, they belongs to, I mean, let's do this question, okay? I will do that question again, okay? No worries. I will do that question after this question. So I will do that question after this question, okay? So no worries. X, B, A and B are real numbers and which belongs to the set 1, 2, 3, 4 or 9 such that x square minus A of fractional part of x plus B equal to 0, okay? So if this is the idea, so what is the fractional part? A fractional part of number looks like this. 1.1 ka fractional part is 0.1, which is a fractional part of minus 0.9, okay? That's the fractional part. So this is a definition you should know. Okay, so let's try this problem out. Let's try this problem out. I hope all you understood the problem. Sabitri Nandri, Shishti Nandri and others, those who were facing problems before. I don't know who these people are. Are you students of Cheenta, guys? Okay, so let's continue anyways. So let's take examples, okay? And let's see this. So let's write. So any number x can be written as the box of x plus a fractional part of x, right? Any number can be written like this. Which class you're in, Shrishti? Yeah. So therefore, this is the box part of x, and this is the fractional part of x, right? So therefore, f square. So let's try to replace this whole thing together, okay? If we just replace x square as x is equal to n plus f whole square, it's n square plus f square plus twice nf, okay? And minus of a of f plus b. So what do you get over here? We get this, right? F square, you take the f over here, 2n minus a, you get this, and the n square and plus b over part here, okay? That's the idea. That's the part equal to 0. All of you got this, guys? Srishti, did you get it? So observe the roots of 1. What are the roots of 1? Can you tell me what are the roots of 1? Can you tell anything about the roots of 1? Observe the product of the roots of 1 is n square plus b, right? All of you agree to this? So I replaced x as n plus f, the fractional part and the box part, and replaced in the equation just that way. And we got this equation. Now observe that it's a function in fractional part of x, right? F. So now observe the roots of f are greater than n square plus are greater than 1, okay? Did you get this point? Because n is a box of x, and what is b? What is b? Tell me. So b is a number from this set, right? And b is greater than or equal to 1. And n is what? N is greater than or equal to 0. And b is greater than or equal to 1. Therefore, n square plus b is greater than or equal to 1. Therefore, the product of the roots of this equation is greater than or equal to 1. Right? Right? All of you got it? Therefore, yes. So therefore, what does it mean? It means that the product of the roots is greater than or equal to 1. Now if one of the, so now to have this one to have a solution, f must be less than 1 greater than or equal to 0, okay? Because f is a fractional, but it becomes less than or equal to 1. Greater than less than 1 greater than 0, okay? And therefore the larger root must be greater than 1. Therefore, what we can tell from here, this equation, this quadratic equation have only one real root less than 1. Okay? Now can you tell me if it has one real root less than 1, then why will that p of 1 equal to 0? So rather my question is that let's see, if taking any equation x square plus alpha x plus beta, okay? Now you know that there is a solution less than 1, okay? So just draw the picture of it 0. Here is 1. There is a solution less than 1. I'm so sorry. Less than 1 and positive. Like this. Say 0. This is 1 over here. Let's say there is a solution over here. Okay. Let's say there is a solution over here. And the other solution is over here. Okay. And observe that the equation is what? It has positive degree. Like positive degree, obviously, I mean positive coefficient of the largest degree. Therefore, the equation must look like this. Like the quadratic equation. Right? And therefore, this p of 1 must be equal to 0, less than 0. Okay, so therefore we get that p of 1 is less than 0. Okay, guys? And therefore this gives that if you put 1 having this y, what do you get? Rather f, you get that 2n plus this is less than 0, okay? All of you get this part? We get n square plus twice n plus twice b minus a plus 1 is less than 0. Okay, guys? So now therefore we know that n is an integer and 2ab are integers as well in this set. Therefore, we have to see that for what n values we have solutions. Okay, so let's check. So let's check the values. Okay, so what is the maximum value of 2ab minus a plus 1? It can be, maximum is a is equal to 1 minimum and b is equal to 9. Therefore, maximum can be 18 and minimum can be b is equal to 1 and a equal to 9. Therefore, minimum minus of it's 3 minus 9 minus 6. Okay, the minimum. Therefore, this can be within 18 to minus 6. Okay, guys? All of you okay with it? Now, n square plus... Yeah. So, n square plus twice n plus is less than a plus a minus 1 minus 2b, okay? Now, observe that if you add 1 to it, you get this one, a minus b. Now, it's equal to n plus 1 whole square, okay? Which is greater than or equal to 1. Since n is greater than or equal to 0. Or is it? No, right? Because n can be negative as well. Box of a function can be negative. A box of minus 2.1 is minus 3. Okay. So therefore, observe that this must be greater than or equal to 0. Okay. It can be minus 1 too. So what we get? A minus 2b is greater than or equal to 0. A must be therefore greater than or equal to 2b. Okay guys, simple. Now I have to put values over here and just check that when it has solutions. Okay, that's it. How many x has solutions over here? Okay, so let's check it. So observe, so it is in a different way over here. So we have got that we just added it up, just like 1. We added it up, n plus 1 whole square. Okay, it will be twice ab na here par. Did I do something wrong? I think this the PPT is given wrong. Or even twice AB, right? Twice B, right? Okay. Okay, if n is greater than or equal to 2, then so it's trying to figure out ranges of n. Okay, if n is greater than or equal to 2, then what we are getting? That a is greater than twice b plus 9. Okay. Okay. Anyways, you can see from here that b must twice b must greater than or equal to 2. Okay, and therefore a must be greater than 11, which is not possible because a must be within 10. Okay, that's the reason. A must be within 10. Therefore, what do we get from here? Therefore, we got that n is equal to is not possible. Therefore, n must be less than 2. Okay, n must be less than 2. That is, n must be less than or equal to 1. We got this range from here. Remember it. Again, what is doing that a is greater than twice ab plus n plus 4 whole square. If n is less than or equal to minus 4, n plus 1 is less than or equal to minus 3, right? If n plus 1 is less than or equal to minus 3, then it implies that n plus 1 whole square must be greater than or equal to 9. Again. And again it tells that n plus 1 whole square plus twice b must be greater than or equal to 11, which is again not possible. Okay, so therefore n must not be less than 4. Therefore n must be greater than or equal to minus 3. Right? So what we got here, n must be less than or equal to 1, greater than or equal to minus 3. Okay, guys? So therefore, we have got a range of n's, the possible values of n's, okay? The probable values of n. The n must be less than or equal to 1 and greater than or equal to minus 3. Okay, we have got these values of n. Now put in these values of n and we have to check these values of n. Okay, so just put in these values of n and you have to check how many values of a and b it's possible. Okay, remember we are asking that a and b, how many a's and b's are possible. Okay, so n plus 1 whole square is less than a minus 2b. Okay, so if you put n equal to, observe, if you put n equal to say just put n equal to 1, what you get? 4. N equal to minus 3, you get 4. Therefore a must be greater than or equal to 5. A minus b must be greater than or equal to 5. Okay, and from here you get various values of a. Okay, so therefore a must be greater than or equal to 5 plus twice b, which is greater than or equal to, b must be 1 or 2. In that case there are two values of a, 7 and 9. Okay, two values of a, and a two values of a and b ka value is 1 comma 2. A b, let's try to create other values. Let's try to create other values too, and we got that. Okay, let's check Let's check for other cases. For a minus b, so for n equal to 1 we have got, for n equal to 2 let's check. Sorry, n equal to minus n equal to 0 के लिए let's check. So n equal to 0 के लिए a minus 2b must be greater than equal to 2. Okay, so therefore a must be greater than equal to 2 plus 2b, which is greater than equal to 4. So therefore for b equal to 1 we have other choices also. Okay, rather it should be asked that how many such a's and b's are possible. Okay, how many pairs of, so I think if you just do it case by case, you can get this total problem in your hands, in your fingers. Okay, okay, so let's go back to the geometry problem now. Oops, let's go back to the geometry problem now. So to the geometry problem over here. So what we have got, we're going to prove here that I hope all of you understood the previous algebra problem. I don't know. I think we will end up by doing the geometry problem today. Okay, so let's check. So we need to prove f dash. So what we remember, what we did in a right angle triangle, the range radius is half into the sum of the two non hypotenuse sides minus the hypotenuse. Okay, so f d dash plus g d dash minus gf. Here we are doing be plus ba dash minus a dash e. Okay, we need to prove that it's same as gc plus ca dash minus g a dash. Okay, that's what we need to prove. Now let's write it down, guys. I think it's very simple. So let's write this down. So let's call this. So let's call the radius side is one length. Okay. So what is this? Let's call this x length. Let's call this length x. Let's call this length y. Therefore, this is y. The whole length is 1. Therefore, g a dash must be 1 minus x, right? Because x plus this is this. Let's call this z. This is z. Therefore, okay. And this is 1 minus z in that sense. And here it is. Okay. Fine. And we can find out the corresponding uh, results from here. Very good. Okay, I get it. So what is CA? CA can be understood as this minus this. Okay, perfect. So it's essentially fixed. Okay, essentially it's fixed. So let's try to find out the values now. Okay, so it is x plus y. So therefore it's half into x plus y. In this case, f d dash is y. Y. G d dash is x. And minus gf is already there. Well, let's see that. A dash b is, we don't know that. Be is 1 minus z, and a dash e is z. And what about this two? Can you tell me those? Or is this really needed? That's my question is to you. We need to use a similarity now, okay, guys? We need to use the similarity conditions now. How do we use the similarity conditions? So x by what? X is corresponding to this angle is corresponding to this angle is corresponding to this angle. So x by GC is equal to x by GC is equal to what? Y by CA dash, right? Right, guys? Did you get this point? Okay. So how do you approach this problem, guys? Like you have to understood that there is a lot of similarity over here, right? So how will you approach this problem in a very elegant manner? Like obviously using similarity, but in a very elegant algebraic manner. That's why the question is posed to you, because life in mathematics or anywhere is not easy problem solving. Okay, you have to work hard for it. GC you're telling is 1 minus y. No, 1 minus, it's not 1 minus y. This FC is 1 minus y. FC is just 1 minus y. You can actually find this out, okay? You can find the root over x square plus y square. You can find this out root over something. You can find this out correspondingly. The 1 minus this minus this, and you can find out relationship, okay? But, and you can find out the sum of the lengths of what it will become. Okay? But do you think that's an elegant solution? That's not an elegant solution, right? But this is not an elegant solution, right? Do you think it's an elegant solution? Therefore, we have to do it in a different manner. That's why the problem is interesting. That's why the problem why it gets interesting for you. What do you think? How will you approach this? Tell me, tell me. So what we're trying to say, the ratio of by which this GCA dash is sort of, it's actually sum of the ratios, like sort of it's a dilation of this, right? It's a dilation of this, right? So it's becoming bigger like this, and it's becoming bigger like this because they are similar. So the sum of the dilation factor, okay, the sum of the dilation factor is actually equal to 1. That's what you have to prove, right? That's what you have to prove, right? Did you understand this far? No, I'm just telling that you have to understand what it means. The sum of the dilation factors is same. That's what I was trying to mean over here. How can you prove that the sum of the dilation factors is giving to that thing, is giving to 1? How can you show that in some sense? How can you show that rather? That's my question to you. Yeah, that's what I told. No, sum of dilation factors is equal to 1. Yeah. So that this angle is this triangle is becoming this, and this triangle is becoming this. So these sides are becoming lambda of this, and these sides are becoming alpha. So alpha plus lambda must be equal to 1, right? So what you have to prove? Just take one dilation factor. You have to prove that, I think somehow someone told this before, okay? That you have to prove this plus this is equal to this. I think someone told this before. Now, did you understand why this is true? Let's try to see this. Let's try to see this again in a different manner. Okay, I'm just trying to make it easy for you, super easy for you, so that you don't get confused. Okay, it's a hard problem. You should be knowing how to tackle hard problems in life, whether it's mathematics or life. Okay, so try to observe this. So observe what? Observe that FG. Okay, let me take a different. So let's take pairs. Okay, consider the angles of say FG is this, GA is G dash A is this. Okay, let's do it in a different manner. Um, let's consider the angle of 90 degree. Okay, opposite the angle of 90 degree, we have FG, we have GA dash, and we have E dash A. Okay, for theta, we have, let's call this theta. What we have? We have D dash G, we have GC, and we have A dash B, the corresponding angles. And for 90 degree minus theta, what we have? This one. We have D dash F, we have CA dash, and we have EB, right? You have that? Now observe what is happening. This is FG is going to G dash A. FG is going to this GA dash by a factor of say lambda. And AE dash is going to this GA dash by a factor of say alpha. Okay. Similarly, G dash G is going to this GC by a factor of lambda because they are similar. And A dash B is going to GC by a factor of alpha. Similar for here. Lambda and alpha. Okay. And therefore, what is happening, guys? Something beautiful is happening. If you just sum up the radius, circumradius of these two small triangles, it's becoming half into, okay, using this result, sum of these two sides, that is alpha, you will get that it's becoming alpha plus this into this corresponding side. GC plus CA dash minus GA dash. It's becoming this, right? So that is the circumradius, in radius of this triangle, which we are required to find into alpha plus lambda. Alpha plus lambda, okay? Now we have to prove this alpha plus lambda equal to 1. The dilation factor is 1. Okay? And we can choose any two sides to show the dilation factor is 1. How to show that dilation factor is 1? Can you tell me? How to show that this dilation factor is 1? Take any two sides and you have to show it somehow. What's on your mind? In radius, not circumradius. So how can you prove this? You have to prove that the sound dilation factor is actually 1. How can you prove this? Think about it. Think about it. I'm giving you some time. Think about it. How can be this equal? I think we will continue pre-RMO. Okay, I will. Let's see. I haven't decided yet. Let's see. Tanish, how will you do this, guys? Now, any ideas on your mind? Yeah, but that's not a good idea. You have to be sort of. I mean, bashing is not a good idea in the sense because you can see something is really elegant coming over here. Lambda plus alpha. That is in fact that's much. That is so interesting now because I mean it's coming out of it in a much more elegant format. So that's the reason I'm just focusing on it much in much more better sense. What is the sum of the? I mean, okay, fine. Okay, go ahead. You go ahead. I really want to give another 2 3 minutes out here. Then I will share my solution. Think about it. Think about it. It's really beautiful. Did you understand till this point, guys? So think about it. It's really one step away, guys. How to do this now? You just prove the dilation factor is sum is 1. How will you do this? Think about it, guys. No ideas? What will the sum of lengths of perimeters of the sides of all the triangles? Can you tell me that? What will be the sum of lengths of all the triangles? All I mean, what is the sum of the perimeter of all the triangles? Hello, guys. No ideas? What's on your mind? Tell me. So, so what's on your mind? Tell me, guys. I'm waiting for you. Nothing? Yeah, the sum is 4. You're right. Perfect. The sum of all so the perimeters is sum of the perimeters is 4. You're right about that. Can I use that somehow? The sum of the perimeters is 4. You're right, Hemant. Think about it. Yes, the sum of lengths of the perimeter of the triangles is the length of the whole square. But how does that help? Does it actually help or not? Let's call this C, A, B. Okay, if this is A, B, C, this must be A. Okay, observe this very carefully. This G A dash must be what? C into lambda. This one will be GC will be equal to B into lambda. Okay, and this C A dash must be equal to A into lambda. Okay. Since these are given here now, what will be this? This will be, height will be equal to c lambda by alpha. This one will be b lambda by alpha, and this one will be a lambda by alpha, right? And this is c lambda by alpha. Right, guys? These are the lengths you got. Now, what are the relationships you have now? Tell me the relationships you can derive from here. Just tell me the relationship. Tell me the relationships you can get from here. Let's rub all this and again write it. A, B, C. This is C lambda. This is A lambda. And this is B lambda. Okay, this is C lambda. Therefore, this is C lambda by alpha. This will be B lambda by alpha, and this will be A lambda by alpha. Okay, we need to show that alpha plus lambda equal to 1. And therefore, this is C lambda by alpha. This is equal to 1. Say. So what are the results we have here? Let's write it. Let's jot it down here. This is the way you should do mathematics, okay? I'm just showing you is the life is not for mathematics person is not really easy, okay? I mean, these 13 people who are those are the real hardworking people, okay? So you should like work hard, like we are doing this problem, not like go away since you're not understanding. If you don't have the knowledge, then it's fine, but yeah, it's okay. So therefore, this is also what? This is A. So if we have A plus C plus B lambda equal to 1, we have this result. We have alpha lambda plus B lambda by alpha equal to 1. We have this result. We have B plus C lambda equal to 1. And we have C lambda by alpha plus A lambda by alpha equal to 1. Okay? So you have this result. Can we prove that alpha plus lambda equal to 1 from here? All of you understood this is the result over here? Can we now prove using this? Do you have anything to add? So we got from here that C plus A into lambda equal to alpha. Okay. We got this result from here. And here we got that C plus A is equal to 1 minus B lambda. But there should be something more interesting, right? What is lambda? We are getting lambda equal to 1 minus B by C. We equated the 4 sides, right? This one, and this one. Anything else we have to do? And here from here we get 1 minus A minus C by B. So we have a relationship between A, B and C from here, which is equal to A square plus B square equal to C square essentially. Now we have a relationship between A, B and C. Therefore we have like one less over here. So we need to show this. How will you do this? Oh, a square plus b square plus c x square plus b square to c square due to this result. Because right angle result. Think about it. Think about it. Four equations. How will you do this elegantly? What do you think? What do you think, guys? No ideas? Yes, no, what do you think? Do you want to think about this in your home? Okay. You want to substitute lambda by alpha in equation 2. Okay, this one, lambda by alpha in equation 2. How will that help? So if you just equate the first two equations, what we get? That 1 minus a minus c by b equal to 1 minus b by c. You just equate it, what you get? C minus ac minus c square is equal to b minus b square. So c square minus b square is a square. So you get c minus ac minus b equal to a square. It's kind of an awkward result, but still. Okay, very good. Think, think, think. Yeah, the source of INMO, you're right. Yeah. So the second equation, A lambda plus B lambda by alpha, is a bit harder, okay? Are you sure you have done it correctly? Is equal to 1. Okay, fine. Let's try to do it. We actually get lots of yeah, maybe that can be a issue, but we need lots of equation of lambdas, okay? So let's try to find out. Actually, I'm doing it in my copy, okay? Let's try to see it. Lambda plus alpha is coming out to be C plus A plus 1 into lambda. Oh, I see. Okay, so let's observe this. Let's observe this, okay? So if you take the last equation, this one, you get that alpha plus lambda equal to C plus A plus 1, okay? into lambda. If you put this first value of lambda over here, what do you get? You get it's equal to 1 minus a minus c by b into this 1 plus a plus c, right? So you get it's 1 minus a plus b whole a plus c whole square by b square. Now do you think this is equal to 1? It must be equal to 1. Now, is our statement correct? I'm just thinking about that. Mm-hmm. Is my correct calculations thick over here? 1 minus b by b, it's alpha. It's correct. Mm, we are getting that. Let's see once. 1 minus a plus c whole square equal to b square. This is what we should get. Means a plus b square plus I see. Actually, a square plus b square equal to c square, and a plus c plus b lambda equal to 1. So here all the things are coming out for the relationship in a, b, and c. Now I'm stuck in this problem. I don't know why. The solutions here seem so easy. I didn't PW plus QV is equal to QW plus QW plus QU. Oh, I see. You know the problem we did over here, I think, I see. We equated to 1, okay? I see now. We have done the same thing. I get the point now. Yes. Okay. So the idea is over like this, okay? If you just check what it's done over here, PW is A dash C, okay? So what is A dash C? It's A lambda plus QV is A dash V. B lambda by alpha is equal to QW, which is BE. BE is A lambda by alpha plus QU is A dash E, which is equal to C lambda by alpha equal to W plus U plus PV. Wait. How is this coming out? Anyway, so what we can do from here is that I see what is done over here. Okay, so W is equal to D dash F. Okay, plus U is equal to GF. Okay, plus, okay, fine. So it's telling that it's equal to same thing that we have done, equal to A plus C plus B lambda. And V is equal to G dash GD dash. Okay, perfect. So it's equal to this thing that we exactly done same here, B plus C lambda. Okay, so we have done exactly the same manner, okay? But the idea is that here we have selected a different set of equations. So just select the different set of equations, okay? Just select this set of equations. The last two equalities. So, yes. So this two equality, if you take this two equalities, that A plus C plus B lambda equal to B plus lambda C, I think you will get it. So what it's telling is that if you take lambda minus 1 into B plus A equal to C into lambda minus 1. I see. Okay, I got it. Fine. Here, actually, we have just renamed. Fine. Okay, so here what we have done is that here we are renamed lambda minus 1 into C minus B equal to A. Okay, so lambda minus 1 equal to A by C minus B we are getting. And similarly, we are getting from here is that lambda minus alpha by alpha will be equal to C minus B by A. Does that make sense? Yes. Fine. Fine. Very good. So we have got from here. Okay. So this is what we have got from here. Okay. So this is what we have got from here. That lambda minus alpha by alpha equal to lambda minus 1 by lambda minus 1. Okay, this equation. Okay, I see now, but here there is a problem. I think it's given p equal to q plus 1. Is it true? Or it should be p plus q minus 1. So therefore, I think if you just factorize it, you will get alpha plus lambda minus 1 as a factor, and therefore if you equate it, it will be 0, okay? So that's the idea, basic idea over here, guys. Also understood the way of approaching. Thanks for like tuning up till this point of time. It's really appreciated. Okay. So yeah, so I'm just sorry for making it too long. It was given over here. But yeah, fine. I hope you got the idea that how I approach problems. That's much more important as a problem solver to your perspective. So you have to like stick around till you get it solved. Okay, that's the idea. Okay, so let's call it a day and good night, all of you, and see you next time. Bye bye.